Okay, hi guys. So we're at another stand with Aidan, and we're at Robotis stand. These guys are from South Korea, and they've made quite a unique robot actually. I've been watching this guy move his hands around. The robot moves, being able to pick it, to pick stuff up and put it down. Quite a lightweight sort of robot. It's got autonomous mobile features as well. But Aidan's going to give us a quick overview of just about the company and just about the robot, right, in more depth with us, okay?
Yeah, thank you. So, hi, we are Robotics from South Korea, Seoul, the capital city. So we are actually specialized for the robot actuators, which is called dynamic cells.
Right,
It's
okay.
a dynamic and cell, actually.
Okay. Makes sense.
So
Yeah.
based on our core technology of the actuators, so we made our own manipulators and also the finger actuators together with, and now we are working on the humanoids robots, but we focus on the manipulation part of the humanoids.
Right.
So that's why we made our it is called AI worker.
Yeah.
So we focus on the like robot which can be deployed on the actual task environments rather than focusing on the local motions, which is bipedal motions.
Right. All
So
right.
yeah, this is the outcomes of it. So now he's actually operating as a demonstration for based on the teleoperation systems.
Yeah.
So you can see the goggles there.
Yeah.
And then based on the goggles, they can detect the figures and structures of the fingers.
Right.
And they can make some the imitation learnings.
Right. Okay. Okay. So, is this are these robots more of a showcase right at the moment, or are they actual products that are ready to go?
So actually, so this one is the for the showcase, but
Okay.
this also can be the data collections.
Yeah.
So
Yeah.
for example, like here's the two visions in here. So they can detect to where to grab and where to place it,
Yeah.
and how much the force we need to provide. Like
Yeah.
those information can be collected.
Right.
And then we can go through the based on these physical data, and we can also go to the simulation side, like Musoko or Isaac Sims.
Right.
And we can combine it all together for the inference.
Right. Okay. And then once you have the data, then you can potentially use that in like other robots. Is that the way that you have it? So once you've captured the data for moving the stuff around, would someone else with a different robot company take that data and use it?
That's actually we are pursuing right now.
Yeah.
So my company recently did the capital raise since we're in the listed company. So we are making that physical action data hub.
Right.
Yeah.
Okay.
So you can think about like that as the factory which is producing the data actually.
Yeah.
We can deploy our hundreds of robots and make them to do some same actions to collect some data. And that is that data is the what our big tech companies are requiring for.
Right, yeah, the data side of it, because you need to understand the human task to actually get done.
Right.
So just so I'm right, but the company's main product or main line is more to do with the component parts.
Yes.
Is that right? Yeah.
Yeah.
Which is essentially like these types of things here.
And every single joint in here.
Yeah.
And this one at Dynamics, the P series is
Right, I see.
and also the Y series is for the every single joints and
Right. So it's the ARM series as well. Yeah.
Yes, right.
Okay. Have you seen your components deployed in other robots?
Yeah, actually, I saw numbers of our customers in this exhibition.
Yeah, they're all around here. Okay.
Yeah,
Okay,
people
good.
can figure out.
Yeah. Okay. And then the systems behind you, is that a collaborative robot?
This one.
Yeah.
This one is also the physical AI tools actually.
Okay.
But it's the concept is exactly same. Here's a leader part.
Yeah.
In other words, masters. And
Yeah.
this one can be considered as a follower, which is slave.
Yeah.
So when this leader arm moves on here,
I'll just move this a little bit.
this robot manipulator gonna make some exactly same synchronized words.
Yeah. I tell you
So-
what, I'm just going to move it just a little bit more. Sorry. Okay, there we go.
Yeah. So as you see here, please. So basically, this is for teaching materials. Right. So same as like that, you can make when you make some certain motions, they will collect it. They will collect some data based on this vision data. It can be the vision or it can be the position data. It's depending on what kind of data you'd like to collect it. But mostly the vision data.
collision day, yeah. And then actually down there, then you got your main components are actually
Yes, right. You
down
can
there,
see
yeah.
our cycloid gears and also the DYNAMIXEL lineups there.
Yeah.
And also you can also check the robot hands.
Yeah.
So which we actually applied on here, equipped them on here. So you can see the single actuators, but we made a link. We linked it each others, so you can make a like actual human motions. Not only the like just
Yeah.
yeah.
It's good that you got that as well. That's a very good.
You can also see the tactile sensor here.
Okay, so you can sense it, yeah.
Yeah. So it's actually not for the torque sensor, but it's a tactile sensor which can be measure the pressure and the direction of the pressure, like where the pressures come from, like this way or this way.
Yeah, and that's quite good.
You can actually track this.
And then, so have you seen this tech be used in like haptics and stuff like that?
Unfortunately, for our application, we do not actually require the haptic motions.
Okay.
So we did not apply for now, but
Yeah.
it doesn't matter that we can. It's optional actually.
And then, can this do like the force of like an egg and something like that?
Oh, it can measure the force.
Yeah.
So we can give a maximum force of the which is suitable for the egg picking.
Okay, very nice.
And also, even though we do not actually put the here, we can actually control the arm. I mean, fingers based on the current control modes actually.
Right.
So
All right. Yeah.
this
That's,
budget feedbacks.
yeah. No, it's really good. Yeah, I'm just looking at it. It goes both ways as well, doesn't it? Yeah. Okay. No, I think that I'll put that down. Yeah. No, I think it's a great overview. Like, yeah, come over and have a look, guys, and obviously we'll put a video together and send it to like over to the team. So thank you. Go ahead. Thank you, bro.
Thank you.
Thank you.
Thank you so much.
Cool.